Hello, everyone. Welcome to Mining Now. Today on the show, we're filming episodes from PDAC, and we've got a first-time company feature on the show. We've got both owners from the company. We've got Duncan MacLeod, and we've got Dag Bilger. He is the owner and business manager, as well as Duncan MacLeod. Gentlemen, welcome to the show. Great to have you on. Tons to cover today, so thank you for joining us.
Thank you. It's nice to be here.
Yeah, thank you very much.
How did you two end up in business together? Let's just start with that.
That's kind of a long story. You want to start, Duncan?
Yeah. When I moved to Sweden 20 years ago, I got a job at a research and development company in Gothenburg that was working on all sorts of applications of MEMS sensors. And that was my first job in Sweden, and Dag happened to be the project manager at that company when I was there. So that's sort of where we met professionally.
Yeah, and I had been working with sensor development, gyros in particular, and had just gotten my first projects as a manager. So I was very happy to do that. And Duncan was my very first, well, not my employee, but my first worker on the project.
Right. And so how long did you sort of get a chance to work together before you went, okay, let's do business together?
Well, that took quite a long time, because we worked for that research institute on a few projects, and one of them happened to be a project about a gyro survey tool for a company in Stockholm. We were living in Gothenburg on the west coast, and basically that project was the most successful of all the projects we were running, and that ended up with us actually being employed by the Stockholm company. So we moved to Stockholm. That company was called Flexit, back then. Yeah.
Yes.
And that was we moved in 2006, I think.
Yeah, around about then.
Yeah. And then that company got bought out by an Australian company called Index, and we worked for them for a few years. And well, it's kind of a long story, but in 2010, November, I think, we started Inertial Sensing and went into business together. Yeah.
It's quite nice to be able to have that amount of time sort of working in those. So you were working for companies, you were working in research together. Sorry, was the research together, was that for an institute, or was that for a company? Sorry, I just misunderstood the very beginning.
It was a government-owned company.
Oh, I see. Okay.
Yeah.
Just for some context for the audience, I don't know much about sort of Swedish research and that. Is that quite prevalent in Sweden, like that, the sort of funding research and sort of innovation? Is that sort of part of the culture?
Yes.
Yeah. So they in Sweden, they got a few big institutes like that. That it's an investment from the government to support transfer of technology from universities to companies, basically.
Yeah.
So was that kind of technology transfer research institute.
Is it pretty successful? Is it pretty successful, that transition from institute to companies like yourself?
Yeah, I mean that I think over the decades, this has been creating a lot of startups.
Yeah.
Also, yeah.
So
also helping. Yeah.
Oh, sorry. No, go ahead. Also helping which?
No, also helping, but it's not just for startups. It's for also helping existing companies,
right,
and large, to modernize technology, to facilitate understanding a certain new area or something like that. And it spans over a lot of research areas. We just happen to work with navigation and sensors in our field.
Let's talk about our heavy industry world tour, brought to you by Savannah Equipment, supplying mining equipment worldwide. We are heading to events across North America and Australia and filming episodes on location. Email us at info@crownsman.com to be part of Crownsman's Heavy Industry World Tour. Orica Digital Solutions seamlessly connects customers' physical and digital worlds so they can readily understand and optimize operations at every step of the value chain, from exploration to processing. Whether deployed individually or as a whole, Orica Digital Solutions technologies deliver intelligence for open cut and underground mines to make more precise and faster decisions. With a complete, timely, and accurate picture, operations can adapt to improve safety, drive productivity, reduce costs, and environmental impacts. To learn more about Orica Digital Solutions, visit orica.com/digital solutions today. Your trusted partner of choice, Bestech Engineering, is excited to announce that they have acquired Spencer Engineering. This allows Bestech to add mine hoist expertise to their existing suite of services, including mining, power, electrical, instrumentation and automation, mechanical, and structural divisions. This diversification will offer clients the highest level of service and value for their projects. Don't miss out on this exciting new chapter of engineering excellence. Reach out today at besttech@besttech.com to learn how Bestech can help you.
Well, let's get into that. Inertial sensing. Tell us about it. Sort of high level. What are you offering the industry? How you already mentioned it, but how long you've been in business? Sort of, just the general info on the company.
In short words, we make borehole surveying instruments. So these are instruments for measuring. In any application where you drill a hole in the ground, people will typically need to measure where the hole is. So it can be mining, oil and gas, civil engineering, tunneling, anything. And you need instruments that you can send down the hole to measure where exactly the holes are.
So,
and that's what we make.
Well, I was thinking, as you were saying, I was like, how am I going to sort of set up this interview? And the thing that comes to my mind, and it's been helpful in other sort of innovative technologies, new technologies in the market, is to tell people what's the old way of doing it. What's the standard, so that people know what we're comparing to. So how would this standardly be done?
The interesting thing is that these instruments have been around for a long time. In the oil and gas, they started the borehole surveying well over a century ago.
Yeah.
So the concepts and the instruments themselves are not new. I mean, you could say, compare it to automobiles, like they've been around for a long time, but there's still innovations.
Right.
Obviously. But what we do is try and progress it in terms of accuracy, the depths you can go to, the power consumption, the safety,
the ease of using the products in the field. But I mean, you can go back to medieval times when they surveyed a borehole. Okay, today we have boreholes that can be 4,000 meters long, 6,000 meters long.
Amazing.
But even long time ago, you wanted to drill a short hole, they would have a line with a little light on, and they held that down the hole, and they could see if the light was going to the right or to the left, etc. Just visually inspecting.
Right. But that just gives you a general idea of which direction the hole was going in.
Right.
But now we have instruments that can, over 5,000 meters, say, you can know within, say, half a degree of where it's heading.
Wow, it's amazing.
What you're after.
Yeah, and if you go back to I guess 1930s or something, nearly 100 years ago, you wouldn't have digital sensors or computers and things like that. So one method they would be using is a photographic method, actually. So they would have a sensor system that could measure inclination and direction in the hole. And the instrument would have like little gauges, little needles, and they would place a camera on top of that. And also have a little timer clock. So they would photograph like a little pendulum showing inclination, and like a little compass needle showing direction, and then a little clock, so you know when you're taking the photo. And then when the system gets back to surface, you take out a little miniature film, and you develop that, and somebody will sit in a dark room and look at the whole film and see okay, that's, and they will also have a log.
Oh yeah.
Of a stopwatch or something. Okay, note down. Now I will take this shot at 50 meters, 100 meters, etc.
Yeah.
And they would actually visually note down all the angles at certain readings, and then they would, with pen and paper, calculate the coordinates of the hole.
I hope our editors can find online some images of that. That'd be quite neat to show.
I think we have some at the office.
But
yeah, please send.
Yeah. Even to this day, there are people who still call all measure instruments of this kind cameras.
Yeah.
Oh, that's where I've seen that.
They call in, I need to buy a camera. And that's the reason.
Right.
Yeah.
Even though there's no cameras
back then, I mean, those systems were fairly big. But as film industry and progressed, the systems would get smaller.
Yeah.
But I think the service systems in the oil and gas industry, they kind of looked like that all the way up to the 80s.
Wow,
when you
that's not
start
that long
using
ago.
electronics,
Yeah.
analog electronics, etc. And I can't remember from the top of my head right now, but I know that, for instance, they introduced like, what would you call that, Duncan? Like it's like, instead of inspecting the film visually, you would have like a digitizer board, feeding it through. And
Yeah, ins- have some sort of optical recognition of the measurements.
Right.
So it would still rely on an optical reading, but a person didn't have to do it.
Right. Yeah. It's so interesting.
Digital camera reading it off. Yeah.
Right. That's so funny that they still say camera, and it's,
Yeah.
because I've seen that, and I literally, I think I just recently saw that and went, okay, I don't quite understand this now. It was confusing me, but now I get it.
That's sort of an older generation thing.
Yeah. I just saw it somewhere, but okay, so when you started the company, what was the first product that you started with? Where was, because you're sort of into refining existing technology, making it better. Where did you start?
Well, we started designing a gyro serving system. So it's basically a system with accelerometers, so you can measure gravity, and gyros, so you can navigate orientation. Because at the time when we started our company, that was kind of the hype back then, to be able to survey a borehole inside the drill rods with a gyro surveying system. And our expertise and background is actually with miniature or MEMS accelerometers and gyros.
Yeah.
So we kind of started out from
because
what we knew.
At that time, the little MEMS sensors were just in the gyro sensors, at least, were reaching a point of their development that they were becoming accurate enough for use in this. That was sort of the key part of that, using these smaller, usually cheaper instruments.
Yeah, so back when we worked with that research institute we talked about, the reason that we happened to start with that there is that institute called IMEGO, they had one of the world's best MEMS gyros. So back in the early 2000s, there were only a few gyros around the world of the right size, small size enough, and high accuracy enough to be able to be used in a borehole survey system. 10 years later, when we started our company, that technology had matured enough that you could commercially buy these on the market. The driver for that was actually, I'd say, the expansion of the gaming industry, little game controllers. And
Okay.
Yeah, because back, like you go back 20, 30 years ago, it would be predominantly, a drive in the military industry. And then it was the car industry. But in the recent, I say 15, 20 years, it's really like, game controllers for your PlayStation or drones and things like that.
Yeah, drones especially now.
Hey, mining enthusiasts! Registration for CIM Connect 2024 Vancouver from May 12th to 15th is now open. Last year, this convention had over 6,800 participants from 60 countries, with 1,796 delegates, 702 booths, and 320 presentations. Secure your spot and register now at convention.cim.org. CIM Connect 2024, where quality and innovation define the experience. Introducing REMscan by Ziltech, the game changer for rapid hydrocarbon soil measurement. Get accurate petroleum hydrocarbon readings in under 30 seconds. No consumables, no wait time. Just scan your sample for on-the-spot result. Perfect for emergency spill response, spill delineation, excavation chasing, and bioremediation monitoring. REMscan is trusted by top industries and backed by independent verifications. Make real-time decisions without the lab wait or expense. Discover more at Ziltech.com or email them at info@ziltech.com. REMscan by Ziltech, the future of rapid soil assessment. In business since 1960, DyeCorp is a leading private manufacturer and distributor of specialty chemicals, equipment, parts, and accessories, serving the energy and mining industries. DyeCorp manufactures and distributes a full line of drillers' edge coring rods, core retrieval systems, and diamond tooling for diamond core drilling worldwide. They also manufacture and sell high-quality Earth Pro drilling fluids and additives for the mineral exploration and energy industries. For more, you can visit them at dye-corp.com or contact their head office at 780-440-4923.
So just so I understand fully, where did you see the gap in the market? because it's such a big decision to go into business together, and now you develop this product. Where did you see that that there was technology now that was coming to a place that could be used, and you were trying to put it together? But where did you see the opportunity?
The gyro that we had worked on at Inertial and built into a survey instrument for the Stockholm company. When we left that to start our own company, that was still the only gyro of that type on the market.
Ah, okay.
So there were companies that wanted a similar instrument for competitive reasons, business reasons. Alternative supplier. They didn't want just one option.
It should be pointed out that actually we didn't leave that company. So it was back in remember in 2008-9, you had a big financial downturn globally. Mining market probably went down by 50% to 45 or something like that. And at that time, the company we worked for and also other companies in Europe were owned by an Australian company. And they introduced a big transfer of companies from Europe to Australia. And they actually made us redundant. So they, in essence, fired us. When we started our company, our first plan wasn't to do borehole surveying systems.
No.
We were thinking about going into surveying drones and things like that.
Oh.
Do something entirely different. But what happened a bit after, in early 2011, we were contacted by a company in Houston that we knew from the past, and they actually wanted us. They asked us if we could develop a gyro for them, and we said, yeah, we can do that. And they said that, well, if you make them, we'll buy them. So it all really started in Houston, in the oil and gas industry. And then we also have a very dear friend in the US, in Coeur d'Alene in Idaho, a company called RockTech USA. And the owner of that company said the same thing, but for the mining industry. So they actually approached us, and we said, well, I guess we can create a business out of this. And that kind of got going by the start of 2011, I think. Yeah.
Wow. So that wasn't even the original concept. That's very interesting.
No, well, yeah, we were faced with a choice after being made redundant of, should we go find new jobs, or, we know some stuff about this, maybe we can apply it to something else. But then we had customers coming to us almost immediately asking if we could do something like Dag said, and it's like, well, if you've got already ready-made customers, you might as well
go. Yeah, that's not a story you hear very often. Yeah, we already had the customers asking us to work. That's nice. So that the gyro that you developed, that's not what's in the back corner there?
No. That gyro no longer. That was outdated quite a few years ago. So
yeah,
we've continued to develop. So the more modern instruments look like this one here.
Okay, yeah, let's bring it up on the.
But any downhole survey instrument basically looks like this.
Right. Yeah. Yeah.
So the electronics are built inside. Most of it. This is a battery, and the electronics are here. This is communication. And then it needs to be kind of big so it sits straight in the hole and it can go down under its own weight.
And what are we again? Let's go back to why is this product? What makes it a cut above in the market?
Well, then you get into a sort of our advantage. I mean, if you bring that one back, Doug, this is a 25 millimeter diameter tool, and this is actually the slimmest available downhole gyro on the market.
Wow!
No one else makes a 25 millimeter tool like this. And that grew out of that was again a request from oil and gas customers, which we have now brought into the mining. This was a few years ago, obviously. But our expertise with the micro electronic systems means we can build something like that, which has all the same accuracy as the bigger systems. So that's one of our key things. And in fact, in one of those, we can also create what we call our twin gyro range of instruments, where you have two instruments in one, basically calibrated tightly together. So you get two independent readings each time you run.
Oh, I see.
Yeah, so you get extra QA, QC, and that's again something else no one offers.
So if you survey borehole in and then out, you actually end up getting 4 surveys, and you can average that data, do better QA, QC. It's not used by all clients, but you know, high-end users, people that want more data, they feel that that's a very good way of running a survey.
Our focus tends to be on the more unique systems, like except because that instrument there, the 25mm slim, will go into holes that other tools can't go into. For example,
Right.
you get narrower holes that it won't fit in.
Right.
And also for blasting, where it's lighter and one person can use it safely because it only weighs a couple of kilograms.
Right.
Yeah, that's actually a little market we stumbled onto by not mistake, but basically we released that SlimGyro in an early version for the oil and gas industry to survey real tight inner tubings of gas well bores. But then we were approached by a few mines who wanted I guess they saw that on the website or heard from our distributors, and they were looking for a lightweight gyro because it only weighs maybe 3.5 kilo, 4 kilos, something like that. And they wanted to survey short blast holes manually with a glass fiber feeder reel, you know, like you have for a sewage inspection. And a big conventional gyro is too heavy to have over your head. It's not allowed by the mine. It's unsafe.
Oh, I see. Yeah, yeah.
But the lightweight and compact size for this tool meant that the workers could actually do this when, you know, in the mine. And so we were approached by customers, and this started back in 2015, I think.
Yeah.
And that actually grew into a really big market for us. And today that there is, like, if you go to gold mine in Africa, for instance, you will find this.
Yeah. It's used by companies like Barrick and Trevally, the larger corporations like that.
You both, you gentlemen, you're touching on something that is for anybody that's in business development or starting a company. You're talking. There's a book, and now I forget what the book's called, and I wish I could remember it. But basically the premise is follow your customers. A lot of people come into business and they've got sort of a concept, and that can be successful too. But then there's the companies that they follow what the customer wants and needs, and they just listen and listen and listen and just follow it. And there's some real success in it, and it really sounds what you've done.
Yeah, that's because we started out as a 2-man team, obviously.
Right.
We've grown some, but we're still not a big company in terms of the core business. And so, unlike if we were a larger corporate with their own vision, our vision is always dictated very much, like you say, by what our customers need.
Yeah.
Give them the advantage they think they need. And so this SlimGyro is the perfect example of that. Someone in the oil and gas industry needed a tool that would fit inside these very slim production holes, and no one else could supply it. So we managed to we had no idea that it would be that difficult, but we managed to do it.
How difficult was it?
The initial order from the oil and gas company was like 4 systems. Not a huge project, but a very important project for them. So we didn't think this was going to turn into like a big volume product or anything. We thought, okay, it'll be a little niche product, but it's money, so we'll do it for the customer. Because, you know, we were doing other business with them. And then in a couple of years, boom, it just grew to be one of the largest products we have.
So are those operated, like, do those have batteries in them? Is it connected with something? Do they go down independently and then get pulled out and have the data? Is that data connected to something? Is it in real-time reading? What's the setup?
Yeah. Basically, these gyros, so they're called memory tools, so that when you run them, the sensor system and the battery is all in the same housing of the gyro.
Oh, okay.
So when you start it on surface, you have typically a smartphone or a tablet or a field computer, and the computer and the gyro they're synchronized. The clocks are synchronized, and then you start the gyro and it goes down the hole. There's no communication, so whatever the gyro does, it records data in the tool, and then when it gets back out of the hole, the data is transmitted to the field computer over Bluetooth. Today we use Bluetooth low energy, but by radio basically, and all the processing is done by the field software in the computer, and then the computer has a procedure, so that if the driller or the surveyor follows that procedure and makes button clicks, these will be logged in the computer, so the computer knows by time syncing when the tool is doing something, roughly like that. And in our industry, that's referred to as a memory survey tool.
So I wanted to then, okay, so does it come with, like I see this, there's another unit behind you called a LiPad 100, is that? And then I saw another called an I don't know if this is a product, but an LK or LKAB.
Okay. No, the LiPad here, that's
Okay.
we distribute that for another company, Northrop Grumman LiTEF.
Okay.
That's a high-end gyro compass. It's actually more of a military grade thing for aligning rigs. So that's not one of the products we make ourselves.
Oh, I see. Oh, okay. Yeah, I was thinking.
That's not a downhole tool. That's for surface work, aligning rigs and other things like that.
Okay. So,
yeah.
So the gyro tool, does that come with other, like, what is that? Is that sold as just that unit? Then people come to you, or packaged together with something?
Various accessories that are needed for the particular type of drilling that's going on, or particular type of hole.
What would those accessories? Can you sort of walk us through what maybe a couple packages would look like? Yeah.
Yeah, sure. For instance, when you survey a borehole, there are different methods for doing that. So first of all, you need a method of conveying the system in and out of the borehole. And some companies, they prefer using the Y-line, either a separate winch or the rig Y-line. So you will attach the survey system to the Y-line, and you will winch it into and out of the hole. And one accessory then that we have is called a Y-line encoder that you place on the top rod of your drill string. And then you can loop the Y-line through that, and it will in real time send Y-line speed and depth to the field computer, so you know where your tool is. Another method is called multi-shot surveying. Then you will pump the gyro down into the hole, and a standard drill rod has a length of 3 meters. And then you trip out the rod string in 3-meter sections. So the rod tally becomes your depth measurement. So that's just a simple method. And then you might have other accessories, such as, if you have a deeper hole, it might take a little bit of time to winch in and out. And sometimes, if you're doing coring drilling, the drilling contractor, the driller wants to take out the core sample. And to save time, you might have a device in front of the gyro called a core retriever, or it's like an accessory where you can latch on to your core barrel assembly and then do the survey at the same time as you're retrieving your core. It's just for efficiency of time. So do you have other examples of accessories?
You have, if you're doing a vertical hole, you don't want the tool swinging around while it's in the hole, just because it's a weight, like a pendulum. So you have what you call centralizers, which are typically some sort of blade arrangement that goes around the sides to hold it in the middle, centralized.
Right.
So those come in different sizes, and then there's various other little things depending on the type of survey you're doing.
So directional drilling, there are some more high-end products when you, on purpose, you want to drill a hole that has a certain, that goes to a planned direction.
Yeah.
And those holes are drilled by directional drilling systems, like a mud motor, for instance. And then the driller needs to be able to know how that mud motor is orientated in the hole. So that mud motor at the back will have a little orientation pin. And then we have an accessory on the gyro, which is called a stinger. It's basically a pointy thing, which will only key in a certain way into the back of the mud motor. And then you can, with a survey tool, you can actually measure how that's orientated in the hole, in which direction and rotation. And then the driller can use that information to adjust the orientation of the mud motor and carry on with directional drilling. So we have survey procedures and also accessories to be able to do that.
But you can think of most of these are all additions that go on that tube type thing.
Yeah, because like I'm looking at on your website. There's mining packages, and you got a picture of a case with all so these accessories will change out depending on what they're looking for. This is not some like off the shelf. It's you talk to the client. they tell you. Now, are you selling directly, or are you going through distribution yourselves?
Primarily through a distributor network around the world.
I see.
Some direct sales, but primarily through distributors.
So like because I'm on your website, and you've got quite a few products. Like you've got the Slim Twins, the Go Gyro, the Twin Gyro. That's the one that some people need too, right? What we were just talking about. Then I saw the BlastGyro. It says on it updated. Is that because it's a new, something additional you've added to the product?
That's when we turned it into a totally integrated unit. So before, this one, before the classic way used to be that the instrument, the gyro, was a tube that you put inside another tube inside the brass barrel.
Oh,
but now it's easier, and you save space if you can build everything inside the brass tube. So that's what we call the integrated tools. Everything's integrated in one. And
right.
Basically, what you do is you screw the battery on and go. So there's nothing else to do. So that was part of that update thing.
And then I saw another product called, and I don't know if it's new, it's called the NorthFinder. Is that built into that tool there as well?
The fatter one, yeah.
Oh, okay. So
35mm one.
And so what is that?
It's basically a version of that. Well, the difference is that basically these gyros that we've showed here a little while ago, they're called reference gyros.
Okay.
So when you survey a borehole, you typically start at the corner of the hole as your first survey station at 0 meters or 0 feet. But an old style reference gyro then needs to be told which direction it's starting in. So it's a hole pointing north or 15 degrees of north. You got to provide that information. A NorthFinder can do all that, but it also has a so-called gyro compassing module. So it can itself determine which direction it's pointing in. It requires a little bit more advanced sensors and technology. It's also a more expensive instrument. And we have been providing that tool since 2015, but only to the oil and gas industry. But this year we're releasing the integrated NorthFinder for also the mining industry.
How have the conversations been at PDAC about it? Have you got a chance?
People have been waiting, and now they are eagerly anticipating being able to order.
We got our first purchase order yesterday and sent the invoice today. So.
Oh, really? Oh, congratulations!
It was something of a launch this week. Yeah.
Well, congratulations. What has it been like? I'm so curious. Like, I know our story of trying to do interviews. I mean, we followed the customers too. We changed our entire business model. We used to do consulting. We don't even do that. We don't have time to consult anymore. Because just the interviews took off. That's what people wanted to discuss, these kind of conversations out to a large audience. They didn't want us telling them how to do it. And so what has it been like, though? For us, it's been quite a journey trying to get into the industry. Now we're sort of established, and we can have lots of fun. But there was some years of pain that led up to that.
It's a real roller coaster, as you probably know.
Yeah.
When you start, you're very, in your first business, you're very naive.
Well, yeah, and I
do not know what you're getting into.
No, not at all. And I'm just wondering, how did you get in with even making your prototypes and then scaling it up to manufacturing? And how did you even just kind of put all that together?
We had experience, even back in the R&D days with Amigo and Gothenburg, prototypes would have to be designed and made for whatever product or project you're working on. So Dag especially would have, you got experience with design and manufacturing.
Well, I was trained by the Research Institute into project management. They had a program for that.
Okay.
Very good manager. His name is Peter Björkholm, a very good manager. He taught me how to run, prototyping and eventually doing it into a product in certain steps. So we kind of knew how to do that for different types of things. So kind of technology and how to do, go from prototype to commercialization. We knew that from several aspects. So the scary parts were more like getting the financing,
right.
That the whole company, it's a basement company. So the first calibration machines we made, I had one in my washing room at home.
Yeah.
My wife wasn't very happy about that, but there was no alternative. And you had stuff in your garage.
Yeah, we were shipping out of my garage.
Yeah.
Yeah, it's sort of like the classic story for
Right.
if you're actually building something.
Yeah.
But, yeah, so yeah, the financial part and getting the money together to make a few prototypes, obviously that was somewhat stressful and risky, but
Another classic is like, I mean, you got to be prepared. I mean, in many cases, you just don't get paid the first year,
Right. Yeah.
So I remember.
Oh, I know.
the only advantage we really had, I guess, is that we knew that there were some highly likely customers that were going to buy and that we could trust because we already knew them.
And you knew where the
Yeah,
technology was.
Yeah, so
you
that
knew.
was utterly invaluable, really.
Well,
They basically told us that, like, if you build a product and deliver it, we'll pay for it. So we knew that was safe.
Yeah.
right.
So it's just a matter of time, so to speak. But
Right.
yeah, it was like the first 14 months, they were a bit hairy money wise. I was, and we were actually during the years, people out of competition and in the industry, they've been like wondering who's the money man behind inertial sensing. Been prodding around us, asking people we know.
But people have been convinced that there's some secret backer.
Right.
But in my case, I borrowed money from my father-in-law. He's a retired army colonel and
Yeah.
it's fairly well off. And so I asked him for a loan and he said, yeah, well, we're going to pay it back. Yeah, I'll do that eventually. I did.
Yeah.
Why,
Yeah.
So-
The backing is your wife being willing to let you store stuff in the bathroom. Right. That's the backing. Yeah.
It went a couple of years before we had to find an actual building.
Yes.
Yeah.
Yeah,
But-
that was 2012 in the spring. We got our first, but also a small basement office. Yeah.
Yeah. But you knew the other thing though is you knew the technology was there. Was that now there's time, there's money, there's the stress of it, but did you know quite early on like this can be done? Like we can make these units. The technology's there. We just need to be able to know how to put it together properly.
Because there we fall back on our previous experience and our education. Unlike many other companies in this industry, we're a little unique in the fact that obviously we're the owners, the two of us. But over the years, starting from the very beginning to even to now, since we both have PhDs and me in physics and Dag in mechanical.
What is it? Oh, yeah,
type of thing.
mathematical physics.
Yeah.
Precise.
But we've been analyzing the systems from top to bottom, especially the gyro sensors. We've had to look at the most raw basic signals and figure out how they can be used, because nowadays there's a lot of these sensors on the market, and you could in principle go take one off the shelf from some supplier and try and make one, but the spec sheets all look very similar. But when you get down to it and try and build a survey system like this, they do not at all behave the same, and some are just not suitable. So we are very lucky in that sense that we can do that analysis, and then we are confident that yes, this will work.
Yeah.
Yeah, and that's actually one of the key. There's many things that are important to make these systems, but before I met Duncan and worked as a project manager, I actually worked on designing micro gyros and micro accelerometers. So I knew the principles, the theories on exactly how they work and what are the problems, and what are the upsides and downsides of these technologies, right? And one key aspect of building a high quality survey system is the ability to calibrate these sensors with respect to temperature.
Okay.
And that's a key thing that I think is lacking among, some of the other systems on the market. We don't have to go through which ones.
As in like heat will affect the accuracy is simply what we're talking about, right? Yeah.
It's basically and one thing we can do is that we can go and buy sensors off the shelf, and we can cherry pick them and calibrate them to much higher performance than the supplier is providing. So we actually individually calibrate every accelerometer and gyro we use in our tools. We calibrate them individually in a a little bit of a lengthy process. And we've designed all the theory, the mathematics, and the calibration equipment ourselves.
Yeah, that's something that we know that most of the competition does not and cannot do. I mean, if you printed out all the documentation just for the calibration theory and how to do it, it would be a stack of paper of about 500 pages.
Well,
We realized.
this is leading me to what I think is an important question, just on the business development side. It's like if you've got, I don't know, like your standard American car, let's say, as opposed to, like a Mercedes or something like that. It's, if you just look at them, you can kind of see that there's some design, it's sort of a step up, but you can't really tell when you open a Mercedes door and then close the door and the sound it makes. You go, oh, this is a different car. This is not the same car as those other 10 over there.
Yeah.
It's you kind of have to feel it. How do you communicate that stack of papers, that expertise that's getting poured into it? How do you communicate that, like, beyond the clients that are reaching out to you and saying, hey, we need this, that next level?
Difficult.
Yeah.
Because obviously there's no quick door closing experience like that.
Right.
The proof of the experience is in the end when customers get the results from their surveys for boreholes and they realize that, oh, we can trust this, and say for the more high-end directional drilling, it's like, oh, we hit the target and there's no unexplained variations in the data that we have to try and smooth over.
Right.
It can be difficult in that regard, but then sometimes it's the more high-end users that you can convince more easily because they're used to looking for that sort of thing.
And they have those technical people that that understand it. Yeah.
And actually, a good point here is that since we started out sort of in the oil and gas industry, or being a provider to oil and gas service companies, those companies, they have really, really hard requirements on the quality of data. I mean, you got to really know what you're doing. If you do something wrong, you're out like real fast.
Yeah.
And
so we were forced to play the hard game.
Yeah, we have a very good friend in Houston. His name is Kim Carrier, and we used to, we started working with him a long time ago. But he's been a source of inspiration and also keeping a keen eye on what we're doing. And basically what we say is, if we can't pass something through Kim, we shouldn't do it. So, and then I guess our distributors, they know Kim fairly well, and most of them. And we sort of use, you could call all that oil and gas experience and meeting up with those high expectations. We kind of use that as a quality mark on the tool. And then we tell the people that are working with civil engineering and mining applications that look, this is oil and gas certified, or it's proven in the oil and gas field. And now we're providing it to you. But I would admit that maybe this thing with how well we can do calibration and how well we can trim things, we should probably get a little bit better on marketing that. It's really like a little weak.
It's a very hard thing to market because it's not visible.
Yeah. Well, I have worked as a consultant, so if you're looking for it, no, I'm kidding. What are a couple? Are there a couple products, though, that stand out, or a couple big wins that your company has had that you get to say, hey, this is a case study, or this is, like I saw one of the notes, like the Swedish Nuclear Fuel and Waste Management Company, I think they did something with you, or is there something specific in mining?
The Swedish Nuclear Fuel, SKB is the abbreviation. That's the government company that looks after the Swedish nuclear waste. That is one of our prouder moments from, was it last year?
Yes, about a year ago.
Because they've been in Sweden at Forsmark, they have the repository for the nuclear waste. And that's being built out as they are anticipating more nuclear power coming online.
Right.
And that requires storing nuclear waste. You can imagine that requires very precise construction of the holes where they're going to store this stuff. And the inclinations have to be very careful so that they don't get water pooling in the wrong places and concentrating the radioactivity, I guess, things like that. So there has to be very precise drilling. and confirmation that the holes are drilled correctly. And so they had a competitive process, I guess, of inviting in the various suppliers of these type of tools.
They even designed a test hole so they had a test facility where they designed a test hole that was designed in a very precise way. And then over a number of years, they invited many providers of survey tools, us and the competition, to run test surveys of that hole. And yeah, we were around there 2-3 times, provided surveys. They wouldn't let us look at anybody else's data.
Right. Yeah.
Not even like how the hole was designed. We provided our data, and they stood next to us and took the data as soon as we were done, downloaded. They didn't even let us touch anything,
Yeah.
They take the data just so you couldn't post massage anything. And,
Yeah.
so they went. That process was quite a long time.
Years, something like
Yeah.
that.
But the track they designed was very, it looked kind of straight, but it had very carefully designed little wiggles up and down and sideways.
Yeah.
So if your tool was not properly calibrated and performing, you would not pick up these little important wiggles. Well, it was specified in the construction contract later that, like, okay, these would be the drilling companies, but the survey instrument has to be the twin gyro.
Twin gyro from Inertial.
Yeah.
Well, congratulations. That's a big win.
That's one of the more outstanding ones. That's from a purely technical point of view.
Yeah, well, I was going to say that sounds like that's the proof of that big stack that you're talking about. If you were to print it all off, that's
exactly.
Yeah. And then what about on the mining? Sorry, go ahead.
Smooth over any bumps. It didn't blow out in one direction or something.
Yeah. Just before we wrap up, on the mining side, is there a case study or a client you've worked with that sort of stands out to you as it's a good, just sort of good base to show this is what you're going to get if you're working with Inertial?
Yeah, I think a good example is when we got a little project with a mine in Namibia, South Namibia, called the Rospinal zinc mine. And this is several years ago. We had been, selling the SlimGyro for blast hole surveying a little bit, but it hadn't really taken off yet. And we got a phone call from this mine, and they wanted to buy one. But they were very clear on one thing is that we want to test it first, and then we'll buy it. So a try-buy situation, basically. And then they said, can you come down here to Namibia and survey with us? And we were like, okay, will you pay for that? Not until it works.
Oh boy.
And so basically we said, well, okay, well, let's use this as a test case then. So we'll travel down to Namibia and visit you and work with you and install everything. But Duncan and I thought, so if we can also get some more data. So basically what we did is we told them, okay, we'll come down for free, but please let us get some more time in the mine, get some more surveys, and we will make sure to do some improvements to the procedure. And the visit went very well. It's a very nice mine, very nice people working with. It's a Trivoli mine, I think, right? And actually that turned into be such a good test case, because it ultimately led to us getting a new distributor for Africa, a company in South Africa called Gyro Mining Services, which is, several years later, our best distributor. And they kind of found us through that test case in Namibia. They saw the results and said that, hey, we want to provide the system.
Yeah, the results there, I guess, proved on a commercial scale that surveying blast holes with the BlastGyro, all these, because when you're doing blast surveys, you've got these rings and there's dozens of holes to survey at a time. And just getting a procedure where that doesn't take all day,
right,
for a bunch of, streamlining all of that and getting the good results and showing that, yes, we can do this. And they were happy because the instruments they were using before did not give the accuracy.
So they did pay for the product, and they did pay for your flights then in the end.
Yeah, absolutely.
Good.
They bought a package in the end.
Good. And you got actually, that's what I want to leave it with, is just your distribution. Do you want to touch on that quickly? Not to put you on the spot to make sure you don't forget one, but just sort of where the distribution is, how it's set up. If you want to even mention anybody, you just mentioned, I think, Dwika. Are there any other ones throughout the world?
Yeah, sure. We can mention the distributors a little bit. So, as we said before, we operate with a global distributor network, and many distributors we have worked with for years. And in South America, but also in Mexico and North America, we have a company called Ingersoll, the Ingersoll Group, and they run our distribution from Mexico or Latin America, really. In the US, we have a company, Rocktech in Idaho.
Yeah.
And they are the mining distributor. And in Houston, we have a company called, it's the Oil Well Guidance.
Oil Guidance Compass Direction.
Yeah. They run the oil and gas distribution in the US. In Canada, we have in the east part in Quebec, we have a company called Mazac Geoservice, close to Val-d'Or. And in Kelowna, in the west, there's a company called Multi-Power Products that we work with. And then you can carry over to Europe. We have a company called Exploration Products that covers Northern Europe. And then we have Central Europe. There's a company in Switzerland called Gyro Services. And then the African continent is Dwika Mining Services that was mentioned before. And then we can carry over we have a distributor in India, which is in Chennai, Prisvin Geomet Services, very, very good company. In Australia, it's a company called Gyromax. And I think we have a distributor in Seoul in South Korea, CNH as well.
Wow.
And yeah.
Wow. So you've covered some ground. You covered some ground. I didn't actually realize it was that scale of distribution. Just a quick, I guess, just to wrap up, and maybe it's the same answer, but maybe just both your perspectives on it. What's next? What's sort of the vision for the company? You seem like the company that does follow the customers, but over the years, what has sort of developed as your vision going forward?
These days, there's a big push for integration of many things in the drilling and measuring the drill holes space. So people want to take these instruments and put them on the drill rigs, build them into the drill rig so that it can all be made more efficient. That's a physical thing. And as a consequence of that, they want the data that comes out of them to be included in that massive data flow that's coming from everything else in the mine. And so you've got this massive amount of data. And as a consequence of that, you've got multiple suppliers of these tools, and they're all coming out with their own sort of cloud data management services. And there's a proliferation of these. And so you can wonder how customers are going to cope in the future. So you say you've got a bigger mine that has various tools running. They can't all run, presumably, 5 different cloud services to get sort of data. So there must be some, what am I trying to say? That there needs to be, in our view, some sort of standardization of because unlike on the oil and gas side, for decades you've had a standardization of the data and the analysis and how the quality control is done.
Yeah, you can basically say, I mean, the mining industry from a data perspective, survey data perspective, is literally, I'd say 20 years behind the oil and gas industry. In the oil and gas, they have there is an organization for standardization of these things, standardization on data formats, performance of instruments, those kinds of things.
Yeah.
And this is entirely lacking in the mining industry.
Interesting.
The organization is made up of, it's a non-partisan group of many competing companies.
Right.
Who put aside the differences and say, well, the data needs to look like this, and this is how we're going to specify how tools perform. And that's just what everyone does. But on the mining side, that
just doesn't exist.
That's absent. And you can't, it's, there's a lot of brick walling that goes on. People, people want to keep their data with their tool and not make it very easy to shift from, say, one cloud service to another.
Right. Yeah.
Whereas our philosophy, even from the beginning, was like, well, okay, we don't really care what you do with the data afterwards. It's your data, and
Right.
you get it into whatever system you want. So going forward, especially as there's just more and more data produced, and people talk about big data and AI and putting all this into things. So there has to, at some stage, in my view, there has to come some sort of standardization
Right.
of our little corner of the market. Otherwise, it's going to it's going to be very difficult for the end users.
Yeah.
Yeah, just given the amount of data, the scale, I mean,
Yeah.
all surveys being done in the world combined with, I mean, the actual cost of drilling and serving these holes. I mean, if you
Yeah.
sum everything up, it's huge amounts of money,
Yeah.
being spent on this. And maybe not as much as in the oil and gas industry, but it's growing. And somewhere you wonder, like, there should be a standardization of data formats and data storage and all these things.
And then there's a sort of a related thing with that is like, since it's become, you could say it's become slightly easier to make a gyro survey tool like we have. And there's been a push to make them driller friendly. So before a gyro surveyor, the person doing the survey would be somewhat educated and skilled in this particular task. But there's been a big push over the last decade to make them driller friendly, so that the actual driller can do the surveying, which is fine. I mean, there's nothing wrong with that.
Yeah,
but
that's a good thing.
But at the same time, there's been a push to do that. There has been a noticeable de-emphasis on the focus on the accuracy of the results coming out. Very kind of subtle, but whereas before you would sell a tool on like, this is highly accurate, you'll get within this and this. That's more secondary now to like
Ease of use.
How supposedly easy it is.
Yeah.
And there you run the risk of it sort of goes hand in hand with that industry-wide standards. Like, there is not a standard on how you can take a survey,
right,
analyze and say this is good or it's inferior results.
Yeah.
So that change in emphasis from accuracy to ease has happened, and it's, in our view, it doesn't really need to happen, because you can build very accurate tools and
that
still make them easy
to use. Yeah.
But we know that that's not what happens in every single case.
Right.
So that's kind of a worry for end users, because they don't understand what they're getting sometimes.
Right.
And getting back to the oil and gas industry, I touched upon that a little bit ago here, is that if you want to be a tool provider in that industry, you have to supply what is called an instrument performance model. It's like a file in a certain format where you have to state accuracy parameters of your tool, because in that industry, that file will be going into a well planning system.
Right.
They make the anti-collision studies and performance studies and things like that to understand what's going to happen. Basically, accuracy of the survey. And that requirement doesn't even exist in the mining industry. And there's one more thing, in oil and gas, it's directional drilling. It's very high-end drilling. But in mining, in the past decade, directional drilling for reaching deeper deposits is becoming more and more common.
Yeah, we just did an episode. We did an episode about it. Yeah, day before yesterday. Yeah.
Yeah, and then, well, I think at least that the industry should take a look at what's been going on in the oil and gas industry. Maybe you don't have to do exactly the same thing, but I think the future would require a little bit of standardization and a little bit of open data formats and things like that.
Yeah, that's a great answer, gentlemen. Like, a lot of times when I ask, sort of outlook of company moving forward, I get lots of different versions of it. But most of it's about growth and stuff like that. That's a very, very interesting answer. That I hope we can clip that out actually as a little highlight, because it's quite interesting. And that comparison to the oil and gas industry is just helping to understand that other industries are doing it. So there's really not a reason for it. It's just sort of been developed this way. Now it needs to shift over. Gentlemen, thank you very much for coming on the show and just letting me just kind of throw questions at you. We've been going at it for a while. And I know you had a show, and I know it's busy.
It's been fantastic.
Yeah, no, it was really fun. So thank you for sticking with us, and I hope you enjoyed it. And I hope this is just the first of many we do over the years, because I know your company's going to grow, and we're going to want to keep finding out more. So thank you very much.
Thank you.
And thank you, everybody, for watching. Very interesting interview and lots to cover. We're going to put links to Inertial's website. They've got a LinkedIn. They've got a YouTube channel. There's only a few videos on the YouTube channel, but they're quite good. And they're quite good graphics to help you kind of understand some of what we talked about today. So please go check those out. Thank you, everybody, for watching. And we will see you on the next episode of Mining Now.